Hi everyone, welcome back to our channel Anvinay Kumar Basics of Physics. Dear students, this is the right place to learn. Dear students, in this video we are going to discuss about the series combination of cells. In electric circuits, the cells are connected in two ways. One is series combination and second one is parallel combination. When the series combination is suitable and when parallel combination is suitable to supply the more amount of current in the circuits. That is the discussing point in this video, and especially we are talking about the series combination, and I will upload the parallel combination in the next video. Clear? You have to notice it. Dear students, what is mean by series combination of cells? When in series combination we are connected, the connection should be like this. Negative terminal of one cell is given to the positive terminal of next one, and so on like that. Finally, we have first positive plate of the positive of the first cell and negative of the last cell. These two only left. In between them, we have to give one external resistance. Then that is called series combination of cells. Clear? So the same thing it is there on board. Look here. A number of cells are said to be connected in series if negative pole or terminal of one cell is connected to the positive pole of the other cell. So very simple. Negative of one is given to the positive of another. Look here, very simple. This is the first cell and this is the second cell and third cell and fourth cell, like that, and so on like that. Here how we are taking the connection? Here in a cell, what we know, the big line is positive and shorter is this is the positive and this is negative. This is the positive, this is negative, positive, negative, positive, negative. Here the negative of the one cell given to the positive of next one. Again negative of this one is given to the positive of next one, like that, and so on. Finally, what we have? Positive of the first cell and negative of the last cell. In between them, we are giving the one external resistance. So that is here R. And every battery cell has some EMF and internal resistance, like this: epsilon 1 R1, epsilon 2 R2, epsilon 3 R3, and epsilon 4 and R4, like that. Every cell has its own EMF and internal resistance. So this is a series combination of the cells connection, children. Very simple. Here all are in a row. Second one, that means what is negative pole of the first cell is joined to the positive of the second cell. Negative of the second cell is given to the positive of third one. Again negative of third one is given to the positive of fourth one, and so on. Finally, what we have? Positive of the first cell and negative of the last cell. In between these two, we are giving some external resistance. Now here you have to go for this. You have to say this is the series combination of cells. In series combination, the cells should be arranged like that. So here you have to notice that, children. In this case, in series combination, external resistance is so greater than the internal resistance of cells. That's why in series combination more current is possible when external resistance is greater than the internal resistance. In series combination, when we can use the series combination means the external resistance what we are taking, that should be very higher compared to the internal resistance of cells. Then the maximum current will passes through the entire circuit. So now we have to prove it, children. Let's go for that. Dear students, if same type of cells are connected in series combination, then what is the total EMF and what is the total internal resistance and what is the current in the circuit? Let's discuss. Here, dear students, we are taken n number of cells. N number of cells. Each one is having some internal resistance is small r and EMF is epsilon. Look here. N number of cells, each of EMF epsilon, internal resistance small r, are connected in series like this. This is the first cell, second cell, third cell, and this is now nth cell. Each one is having some EMF is epsilon and resistance is r. Again epsilon r, epsilon r, epsilon r, and so on like that. This also epsilon r. In between first cell, last cell, some r is, capital R is there. What is capital R? External resistance. External resistance. In between the first cell and last cell, some external resistance is connected. Now it is the series combination. So children, here you have to know, when all the cells are connected in series, the net EMF is nothing but epsilon is equals to epsilon 1 plus, I am writing here, net EMF. Epsilon is equals to epsilon 1 plus epsilon 2 plus epsilon 3 and so on, epsilon n. This is the formula for net EMF in series combination. In series combination. That's why here what you have to say, already we are taken epsilon net is equals to what here? Each one has equal EMF. That's why we can write like this, epsilon plus epsilon plus epsilon, and that should be like n times. N times. That's why what write, epsilon net is equals to n epsilon. What it is? Epsilon net is equals to what? N epsilon. Net EMF is what? N epsilon. You have to remember this one. Net EMF is equals to what? N into epsilon. In the same manner, we have internal resistance. So here you have to remember children, in series combination of resistors, what is the formula? R is equals to, R net is equals to R1 plus R2 plus R3 plus and so on, Rn. This is the effective resistance in series combination of cells. That's why here what you have to write children, in this case what we have taken, each cell has internal resistance small r. That's why we can write R net is equals to R plus and so on R. Then obviously what write, R net is equals to NR. So this is the formula we can use in only series combination. You have to remember, in series combination the effective resistance given by the formula R1 plus R2 plus R3 plus and so on Rn. In this case what we are taken, every cell has same resistance. That's what right, R plus and so on R n times. So then obviously what we get, R net is equals to NR. That's why here I am going to write net internal resistance. What it is children? S R net is equals to what? NR. What it is? Net internal resistance only. Now in this circuit you can observe total resistance is what? What is the total resistance? So you have to observe in this diagram, all the cells are connected in series with the external resistance. That's why what you have to say, the amount of resistance NR, that should be in series with the capital R. That's why we can write total resistance. In the circuit. What is it children? Very simple. Here the effective value already simply here. If you want to write like this, very simple here. Here I am writing the entire combination should be expressed like this. Like this. Now this is the what it is, effective value of all the cells, effective value of all the cells. So that's why here in this case what, right, the EMF is n epsilon and internal resistance is nr. Clear? The simply the effective value should be written like this. Here this is the cell has EMF of total EMF is what, n epsilon, and total internal resistance is what, nr. Now this nr and this external resistance are, how these two are? In series. How these two are? In series combination. That's why here the total resistance can be written as, here what, right, in series combination formula is what, R effective is equals to what, R1 plus R2, like that we have in series combination. That's why here R1 is what, here nr, RT is what, R. That's why here we got it right. So nr plus what it is, R. So this is the total resistance in the circuit. What it is, nr plus R, nr plus R. Now children, we have to write the expression for total current. Total current we have to write that one. Very simple children, very easiest one. If you can understand this one, then you can easily understand the next coming topic also. Here what we have children, now current, total current is equals to, so children what we have, according to Ohm's law, formula is what, according to Ohm's law formula is what, V is equals to IR, I is equals to what, V by R, like that. Here total current is equals to, simply what, right, total EMF by total resistance. This is the formula for finding the total current in the circuit in series combination of cells, children. So already we derived, what we derived here, total current is what, I, and already we are taking total EMF is what, n epsilon. What is n epsilon? So n epsilon by total is what, nr plus R. I is equals to n epsilon by nr plus R. So this is the equation number 1, children. So in series combination, in series, capital R is so greater than small r or nr. Then what, right? I is equals to n epsilon by R. That means we are neglecting the term nr. Clear? In series combination, external resistance is so greater than nr value, then we can omit this one. Simply what, right? I is equals to n into epsilon by R. So this is the current in the circuit. Clear? So children, if the same circuit is with only one cell, then what's happened? I is equals to n into epsilon by R. This is equation number 2, children. What it represents? It represents the current in the circuit of series combination. Simply what, right? Current in the series combination of cells. Clear? I is equals to n of epsilon by R represents the what, amount of current in the series combination of cells. Clear? For example, if only one cell is connected, like this. This is the cell, and that should be given to like this. Clear, children? So only one cell it is there, that should be here having some epsilon is the EMF and R is the internal resistance, and this is the R, capital R. Here capital R is what? External resistance. Then what we write? Current value in this case, I is equals to EMF by total resistance. Here the current in the single cell, I am taking, that is IS. What is EMF here? Epsilon by total resistance. Here internal resistance is R and this capital is the external resistance. These two are in series. When series combination, what write? Like this, Re plus R. So Is is equals to epsilon by R plus R. This is what, children? Amount of current in the circuit having only one cell. So in this case also, R is so less than capital R. Capital R is so greater than R. Then what write? Simply we can write Is is equals to epsilon by R. Clear, children? In this case, same thing. When external resistance is large, external resistance is larger or heavier than the internal resistance, what right? Is is equals to epsilon by R. This is the amount of current in a single cell. Amount of current in a single cell. So this is what? Amount of current in a single cell. Now this is equation number 4, children. Equation number 4. Now you can substitute that 4, equation number 4 in equation number 3, equation number 2. What it is? Is equals to epsilon by R. Here what it is? I is equals to N into epsilon by R. I is equals to N into epsilon by R. What is meant by epsilon by R? Is. Is means what? Amount of current in the single cell. That's why here what you write? I is equals to N into Is. This is the current in the series combination of cells. Look here, children. I is equals to N into epsilon by R. Epsilon by R is what? Current in a single cell, and I is equals to N into Is. That means what? The amount of current in the combination of cells is N times than the amount of current in a single cell. Clear? That's why here the amount of current in the series combination of cells, that should be N times of current in the single cell. That's why what you have to conclude, children? Simply here, look here once. Amount of current in combination, that is what? I is equals to N into current through a single cell. So this is the effective current in the series combination of cells, children. That's why here you have to remember what it is. I is equals to N into Is. This is applicable when external resistance is very larger than the internal resistance, then only it is possible. That's why what we have to conclude, children? We have to conclude that the series combination of cells is preferred to supply the more amount of current in the circuit under one condition, that is what? External resistance is greater than the internal resistance. So children, this is about the series combination of cells. I hope you understand this one. If you can understood it, like, share, comment the video. If you can have friends like you, then share our channel to your friends also. Thank you for watching.